Okay, so there's something called tabular integration, which is super cool. It's like a trick way. It actually used to be one of my favorite things when I took Calculus 2, like forever ago. But essentially, basically, if you have two things that are being multiplied to get two functions that are being multiplied together, and one of the functions, as you keep taking the derivative, it eventually goes to zero, you can use this tabular trick, okay? So if we look over here, we know that x cubed, eventually if we keep taking the derivative, it'll go to zero. So that's how you choose your u for the tabular. So we're gonna let u be equal to x cubed, and the remainder is going to be e to the x dx, okay? So now, for our tabular trick, we make a t-chart, and we are going to be taking the derivative of u, and then we're going to be taking the antiderivative of dv, okay? So as we take the derivative, we get bring down the 3, subtract the 1. Bring down the 2, subtract the 1. This will just be the number, and then number derivatives are 0, okay? One thing that you do have to remember whenever you're doing tabular, it's always plus, minus, plus, minus, plus, minus, forever, however long you're going, okay? You always start with the positive, and then you just alternate back and forth, okay? So our dv is e to the x. If we take the derivative of e to the x or the antiderivative of e to the x, we always get e to the x, so it just goes straight down, okay? And then for the tabular method, all you have to do is start from the top and then do this little diagonal thing, okay? So we're going to take x cubed and multiply it by e to the x. So that's the first one, and it's positive. Then we're going to take negative 3x squared and multiply it by e to the x. Then we're going to take positive 6x and multiply it by e to the x. And then we're going to take negative 6 and multiply it by e to the x. Because we're not evaluating it, we're going to add the plus c, and that's the answer, okay? You can do this the same way that we did previous problems using the integration by parts with Lipit, but this way is way easier. So however you want to get to the answer is A-okay.